deadliest threat from war isn't the weapons, but bacteria. New research from war-torn Ukraine has uncovered Pandrug-resistant bacteria, pathogens so dangerous that even the strongest antibiotics are powerless against them. These macroscopic invaders could be the next global health crisis, spreading silently but devastatingly beyond borders. Hello everyone, and welcome back to Science Codons, where we dive into the latest and greatest in scientific discoveries. In today's episode, we're diving into a hidden but equally disastrous front of the war in Ukraine, the battle against Pandrug-resistant bacteria. A recent study published in the Journal of Infection highlights the extreme pathogenicity and alarming resistance of these bacteria, which pose significant threats to global health. Let's dive into the details. Wars have historically been breeding grounds for diseases, but the war in Ukraine has escalated this phenomenon to a novel microbial challenge. In the context of damaged healthcare infrastructure and overcrowded, resource-limited hospitals, bacteria are developing resistance at concerning rates. This phenomenon is worsened by a lack of proper sanitation, insufficient medical supplies, and high patient density, creating the perfect storm for the proliferation of multidrug and pandrug-resistant bacteria, pathogens resistant to every known antimicrobial agent. In a landmark study published on October 11, 2024, researchers from Lund University, in collaboration with Ukrainian hospitals, examined the prevalence of multidrug-resistant and pandrug-resistant bacteria in war-wounded patients. The study focused on 141 individuals, 133 adults injured during the conflict, and 8 infants suffering from pneumonia. These patients were treated in hospitals that, despite their heroic efforts, were overwhelmed and severely under-equipped due to the ongoing war. The findings were surprising. Researchers identified a high prevalence of multidrug-resistant and pandrug-resistant gram-negative bacteria. These pathogens are famous for their ability to withstand even the most powerful antibiotics. A shocking discovery was that many of these bacteria were resistant to last resort drugs, a term used to describe antibiotics that are used when all other options have failed. This leaves healthcare workers with almost no treatment options. A researcher described the bacteria found in Ukraine as the most resistant he had ever encountered, which underscores the severity of the crisis. Key insights from the study revealed that the bacteria were predominantly acquired in hospital settings, particularly during emergency surgeries and intensive care treatments. They exhibited advanced resistance mechanisms such as extended-spectrum beta-lactamases and carbapenemases, enzymes capable of neutralizing even powerful antibiotics like carbapenems. These mechanisms essentially render the antibiotics ineffective, allowing the bacteria to survive and multiply. Alarmingly, some strains showed complete resistance to all tested drugs, qualifying them as actual pandrug-resistant bacteria. But the question is, what are the broader implications? The rise of such bacteria in Ukraine is not merely a local problem. Resistant pathogens do not respect borders. With millions displaced by the war, these superbugs have the potential to spread internationally, putting global health systems at risk. This crisis is a sobering reminder of the global threat posed by the antibiotic resistance, often termed the silent pandemic. The World Health Organization has warned that we are approaching a post-antibiotic era, a time when routine surgeries, childbirth, and minor infections could become life-threatening due to the lack of effective treatments. In this era, common infections could once again be deadly, as they were before the discovery of antibiotics. In the end, what can we actually do about it? Despite the grim findings, there is hope. The collaboration between Lund University and Ukrainian researchers highlights the power of international cooperation. By sharing data and expertise, scientists can develop strategies to mitigate the impacts of antibiotic resistance. Additionally, innovations like bacteriophage therapy, which uses viruses to target bacteria, and research into antimicrobial peptides offer potential alternatives to traditional antibiotics. However, these advancements require significant investment and political will to bring them to scale. The war in Ukraine has exposed the fragility of our defenses against microbial resistance, but it has also showcased the resilience of science in tackling global challenges. Let's hope this crisis serves as a wake-up call, inspiring action to prevent further loss of life both in Ukraine and across the globe. That's all for today's episode. Thank you for joining us as we delve into the unseen battle against antibiotic resistance emerging from the war in Ukraine. If you found this discovery as fascinating as we did, make sure to give us a thumbs up and subscribe to our channel for more amazing science content. Also, don't forget to check our website, which is sciencecodons.com. Until next time, stay curious and keep exploring.